Good evening, guys. Maybe good morning to some people from the Western country. Again, welcome to PySpark certification, an interview question for machine learning PySpark through the PySpark. So before we start, I am sure to all to see my screen. We can start session now. Today agenda of this session I am going to explain you guys what is the machine learning, why is machine learning important, and what the different type of the machine learning, and how to choose right machine learning model, and last is demo part. So guys, one question is everyone mind, why should I use machine learning? So guys, machine learning is very important for the make decision fast, make data driven decision, make decision faster than other, execution decision faster, and recommendation engineer or common use case for machine learning. Other people use include fraud detection, spam filtering, malware threat detection, business process automation, and predictive maintenance. Such type of the operation you can operate through the machine learning. Then what is the machine learning? Machine learning is a type of artificial intelligence that allow software application to learn from the data and become more accurate predictive outcome without human interaction. Then why is machine learning importance? Why machine learning is importance? Machine learning is important because it gives a view of the trend and customer behavior and business operational pattern, as well as the support the development and new product. Many of today's leading the companies such as Facebook, Google, and Uber make machine learning to centralize part of their operation. What is different type of machine learning? Machine learning basically four type, that supervised machine learning, unsupervised, semi supervised, and reinforcement learning. We have to explain one by one. Supervised machine learning basically used for the labeling data that and continuous data, and basic operation, that binary classification divided data into two category, multi-class classification, regression modeling, in assembling. These are operation will be used for the supervised learning. Unsupervised basically non-label data, used for non-labeling data, and such unsupervised learning algorithm are good for the following tasks: clustering, splitting the data into groups based on the similarity, identify unusual data point in the dataset, association mining, dimensionality reduction, reducing the number of the various in data sets. Semi-supervised learning. Semi-supervised that used for the unlabeled, both problem task label and unlabeled data. Both are involved, labeling and unlabeled data in semi-supervised learning. And used for the machine translation, teaching algorithm to translate language based on the less than full directory of words, fraud detection and labeling data. And reinforcement learning, basically this algorithm learn to interact with environment and the algorithm adjusts itself based on feedback. Such type operation, robotics, video gameplay, resource management, these are the type of the application you have used reinforcement learning algorithm. The type of algorithm data scientists choose they use depend on what type of the data they want to predict. And fourth, that how to choose right machine learning algorithm. This question is also asked to interview question, how to choose to write machine learning model. Yes, such type the suppose you have been given data set, how do you decide on which machine learning algorithm use, how to start. Such type of the question is asked to interview. Then such type, then there is no master algorithm which can fit any data set. Start with understanding the data, visualizing the data set can give a good starting points. If data show linearity, then go to linear algorithm may be good to start. If data show seasonality, time series can be go to start. For non-linear interaction, deployable and easily understandable model like decision tree, regression tree model may be good to start. Black box algorithm, live SVM, support vector machine, GBA, gradient boosting algorithm. To work on image, video, natural neural may be good to fit. Pattern recognition, artificial neural network is good to start. Image processing, convolution neural network is good to start. Speech text recurrence neural network may be good to start. Okay, guys, perform the basic operation through the PySpark, reading the CSV file, define the schema, exploration using PySpark, check the data dimension, describe the data, missing value count, find count the unique value. Such type of the operation we have the through the Google Colab demo. Let's go to demo parts. I have the data India and Bangladesh cricket match. Such type of the data column name and data types. Batman's unique ID. Batman name. Bowler ID is unique. Bowler name. Details. This match ID. Each ball. In boundary. Each wicket. Over. Runs. And time stamp. Such type of the column is available for the data sets. And then again, to run in PySpark Colab, we need to first install all the dependency in Colab environments. We have the run this, and it is successfully completed all the dependency and created environments. Then create Spark session. If you need to check spark.version, you can also check here. Write the command. And pip install PySpark, also install the dependency in Colab environments. You can check also Spark session in memory, Spark context, version, you can check version, master and app name. And reading the CSV files. CSV file is here. You can upload also. Click the upload. India. Ban comments CSV. We have the call this file, and we have the also you can find the path, copy to path here and put the comment. Okay, you can also print schema. You can also give the columns and data types. Same we have the also explain here, that's it. Column names and data types. You can see the print schema also got it. And drop column from the data. Machine learning project, we have the always sum of few columns is not required to solving the problem. We can use drop function to remove column from the data. As strict sign before list, dropping multiple column from the data set. Write seva data dot drop asterisk Batman, bowler and ID. They not required column, we have to remove that. And next part, exploring data. Check data dimension. You can write seva dot count. You get length seva data frame dot columns. Got it here. And describe data function give you most of the static results like the mean, count, min, max, standard deviation. You can find the describe function. You can use summary function, particularly the numeric variable as well. Get summary numeric variable. Data frame dot select each ball, each boundary, run and describe. We have the give the output below. Missing value counts. It is rare to get data without any missing value. It is important to check all the number of missing value present in all columns. Knowing the count help to treat a missing value before building any machine learning model using the data. Import SQL function. and null value each of the column. You can check the null value each of the column. Value count column. We have the write a group by function Batman's and count. Encoding category variable using PySpark. Most of machine learning algorithm accept the data only the numerical form, so it essentially convert any categorical variable present in our dataset into numbers. Remember that you cannot be simply drop from the our dataset if they might contain useful information. String indexing. We have the right the PySpark ML features string indexer on hot encoder pipelines. Basically, combined component of the through the PySpark we have the run machine learning codes. String indexing is similar to label encoding, assigned to unique integer value to each category. 0 is assigned to most frequently category and 1 is next most frequent value. Then run to PySpark.ml. What is PySpark ML? Machine learning. It is data frame base of the machine learning API to let user quickly assemble and configure the practical ML pipelines. What is pipeline? What is ML pipeline and how to works? It is the common to run sequence of algorithm to process and learn from data. Split each two documents text into word, convert text document to word into a numerical features vector. Learn to predict modeling and feature vector on label. MLlib represents to such as the workflow as a pipeline. A pipeline is a spatial as a sequence of the stage, and each stage is either a transformation or estimator. For transformation stage, the called transformation methods is called on the data frame. For estimator stage are the fit method to call the procedure in transformation. Then next part is the string indexer. String indexer encode the string column of the label. To the column of the label, it is the input column in numeric we cost it to be string and index in the string value. Such type of that create string index class in specify input and output column. We have the apply Batman column. Batman column is the string column. You can also get the Batman's column name is string type. You can also see here. Batman name is a string types. Batman name is string type with different label. Apply string to indexer with the Batman's name is the input column and Batman index is output column. Batman name is input column and output column is Batman index. Same apply to baller name and baller index. We have the convert string to index is that integer. And next is that on hot encoder. On hot encoder is technique for the converting categorical data attribute into binary vectors. And we cannot apply one hot encoder to be string column directly. We need to first convert string column to numeric value. For that we can use string indexer value. For that we will use string indexer. After that we can apply on hot encoder. Then next step, transform the data, fit and transform, and view the transform data. You can data frame dot select and select the particular column Batman name, Batman index. We have the convert same indexer, Batman name and Batman indexer. You got the such type of the data if converted by through the string indexer. Okay, then next is create object specific input output through the on hot encoder. Input column Batman index and baller index. We have the provide Batman OE and baller OHE. Transform data to fit and transform. Then next step, view the transform data frame dot select. We select the column and show the top 10 record. You can get the indexes same, and it is baller OH is it is vector format. We have to provide the output. That's then again vector assembler, specify input and output column to be vector assembler. You can put the column name Batman index, baller index, and fill the null value through the fill NA function, and transform the data through the transform methods, and then select vector, show the output. That's building machine learning pipeline using PySpark. Pipeline as the maintains data flow of the relevant transformation. It are the required to reach to end results. Same we have the call PySpark.ml.pipeline. I will use in decision tree classifier. We have the same, we have the provide, create a data frame, create a simple data frame, and ID, category 1 and category 2. So it is such type of data, ID a category 1, category 2, and then apply the transform category column 1, and same transfer to category, transfer 3 hot encoded the change to string to numeric value, and set up the pipeline, stage 1 and stage 2, stage 3. And then pipeline model and transform the data in defines. And then transform data we have the so that. Then same is we have the apply the logistic regression. Logistic regression basically describe the value binary value like 0 1 yes no true false such type operation. We have the logistic regression we have the use. Same we have the provide create a data frame and then feature 1 feature 2 feature 3 feature 4 and labeling. And then we have the same we have the convert the transform column feature 1 feature 2 and same we have the stage obtain the output stage 1 stage 2 stage 3 stage 4 and vector assembler we have the convert string value to numeric value and then apply the logistic regression feature code. We have the provide the column features and label, then set up the pipeline and test and train data. They have the fit and transform data. That's train data. We have the regression pipeline dot fit and then we have to select the operation, generate the column features label row partition probability predict and so. And then to test and model we have to create one another simple data set without label, feature 1 feature 2 feature 3 feature 4 does not label, does not contain any label such type. Then transform the data using the pipeline. So predict the test data features is vectorized form row prediction and probability and prediction 0 and 1. The model work the PySpark let test data in model now. Same we have the create stage 1 string indexer input column Batman name output column Batman index. Same we have the provide the baller name and baller index. And we have the call vector assembler input column and output column is feature. Then apply the logistic regression features and labeling for the baller index and set up the pipelines and then apply regression pipeline fit for train data fit and test data we transform that. And then we have the predicts your probability and prediction so that. Now you are familiar with the basic step needed to start your journey through the PySpark and Google Colab. Hopefully we will meet again with more interesting area of PySpark with Google Colab. Thank you for watching so far. I hope you learned something. If you enjoy my video, please subscribe my channel and press the bell icon to get new video updates. Thank you guys so much for watching and subscribe to my channel. Right, we are good to exist our session. Again, thank you everyone.